Hello, and welcome to the Research Methods course. Today's topic is causation and experimental design. Let's make sure we're all clear on the terminology. Independent variable is a variable that is expected to influence another variable. Dependent variable is the variable that can change depending on the influence of independent variables. Dependent variable is usually the outcome that we're studying. For example, let's say that we're studying what interventions would be effective in decreasing the rate of smoking. Major interventions that have been implemented is increasing the tax rate on tobacco products, launching public health campaigns, and banning indoor smoking. So in this case, we have three independent variables. The first one is the tobacco excise taxes. The second one is indoor smoking ban. And the third one is other public health campaigns. The dependent variable in this scenario is the rate of smoking among the population. Another term that is very important in this course is causation. What is causation and why is it important? In order to solve social problems, we need to know what causes them. There is a causal explanation when we can demonstrate that independent variables produce a change in a dependent variable. In the earlier example, our dependent variable is the rate of smoking. In studying the effectiveness of smoking prevention programs, we would need to show that independent variables, which in this example are tobacco excise taxes, ban on indoor smoking, and public health campaigns, in combination cause a reduction in the percentage of Americans who smoke. We often hear the terms correlation and causation. What is the difference? Social scientists have observed that when ice cream sales increase, the rate of homicides also increases. These two variables are correlated, but it's a statistical coincidence. A variable that is relevant here is the weather. Warmer weather leads to higher rates of violent crimes. So this is a relationship where we can prove causation. Correlation among two variables that are not logically related to each other is referred to as spurious correlation. Spurious relationship is a relationship between two variables that is caused by a variation in the third variable. In the example of ice cream sales being correlated with higher violent crimes, the third lurking variable is the warm weather. You can take a look at other examples of fairly entertaining spurious correlations at the website listed on this slide, tylervigen.com, Spurious Correlations. In case the text is not legible on this slide, the kid says, "I wish they didn't turn on that seatbelt sign so much. Every time they do, it gets bumpy." So an individual exercise for you is to figure out what's the lurking variable in this situation. Another set of terms that is often used together is correlation versus association. Association is any type of relationship between two variables. Correlation is a linear relationship between the variables. An example of a linear relationship between two variables is the number of personnel versus employee costs. For each unit increase in the number of personnel, there is a proportional increase in employee costs to an organization. An example of nonlinear relationship is population growth over time. It took over 200,000 years for the population on our planet to reach 1 billion individuals. Over the next 200 years, the population exploded to 7 billion people. So this is not a linear relationship. Correlation could be positive or negative. In the example of anti-smoking policies, we observed that an increase in the excise taxes on tobacco results in the decrease in the rates of smoking. So this is a negative or inverse correlation between these two variables. You're now well familiar with this chart depicting the research process. In today's lecture, I will begin a discussion about different methods that you can use to collect data for your study. The first research method is experimental design. The second method is non-experimental design. And the third type of research methodology is broadly defined as quasi-experimental design. In academic research, the best way to prove causality, that independent variables cause a change in a dependent variable, is through randomized experiments. In randomized experiments, there are at least two groups, a participant group and a control group. Participant group is also referred to as the treatment group, as in a group that receives treatment or an intervention or program services. Randomization is a technical procedure to ensure that the control group and program group are comparable to each other. Key features of true experiments include at least two groups. One is the experimental group, and the other one is a control group. You could have two or more experimental groups in which these groups receive different interventions. For example, if this is a drug trial, experimental groups could receive different doses of a medicine being tested. Another feature of a true experiment is that assignment to groups is random. And the third feature of a true experimental design is that a researcher can change the treatment or the intervention given to the experimental group. This slide shows you a design of an experimental study. The hypothesis is that a medication X causes a decrease in the anxiety level. In this study, we have two experimental groups and one control group. Each group has 200 participants who were randomly assigned to different groups. Experimental group number 1 receives 100 milligrams of medication X every day. The second experimental group receives 250 milligrams of the same medicine. The control group receives a placebo, a sugar pill. In the experimental group number 1, 90 of the participants see a decrease in their anxiety level within 3 months of starting the drug regimen. In the experimental group number 2, 190 of the participants see an improvement. And in the control group, only 10 participants report a decrease in their anxiety level. We can conclude that 250 milligrams of medicine X is an effective drug regimen for people suffering from anxiety. So far, we have heard a lot about the importance of random assignment of subjects to different groups. Not only individuals can be assigned, but so can groups, such as elementary school classes, for example, or program staff. Geographic areas can also be randomly assigned to treatment or control groups. Time periods can be randomized as well. For example, if you are studying how different types of patient engagements impact health outcomes, you can select patients who arrived at the clinic between 10 and 11 a.m. to a program group, and then those who arrived between 11 and noon to a control group. When you randomize large aggregates, such as cities or neighborhoods, it is recommended to use stratified random sampling, which, as you hopefully remember from the last lecture, involves dividing a population into smaller groups referred to as strata. Control group and program or treatment groups do not have to be the same size. In fact, treatment groups are often larger in cases when there is a clear benefit to the participants. I have discussed methods of random sampling in the previous lecture on sampling. The difference between random sampling and random assignment is that in random assignment, we're dealing with individuals who already agreed to participate in the study. Methods of random assignment could include random selection through a random number generator, It could also involve randomly selecting the first unit and then every nth number. You could also roll the dice or use lottery-like selection. In any type of a research project, the issue of validity is important. Internal validity of a study has to do with the degree of confidence that the causal relationship you are testing is logical and not influenced by lurking variables. External validity has to do with whether or not the results of the study can be generalized to other groups. For example, if you are conducting a qualitative study based on 25 or 30 interviews, external validity is most likely not going to be very strong because of the small sample size. This does not mean that your study results are invalid. It just means that they might not be generalizable to other groups that are qualitatively different from the group that you studied. There are several factors that could undermine internal validity. One of these factors is selection bias. If assignment of study participants is not randomized, participants who select to be in the treatment group could be qualitatively different from those who choose not to participate. This is often an issue with programs like smoking cessation programs. Individuals who sign up to participate in a smoking cessation program are likely to be more motivated than the general population of smokers. So the results of the smoking cessation program might not be generalizable to the entire population of smokers. Another factor that could undermine internal validity is history effect. This is when external events occur during the experiment, and they, as opposed to the intervention, could account for changes in the outcome or the dependent variable. Differential attrition is another threat to internal validity. This is when groups become qualitatively different from the start of the experiment because more participants drop out from one group than from another. Contamination is another factor that could jeopardize internal validity in studies. Contamination occurs when treatment group and control group affect one another in ways that are relevant to the desired outcomes of the study. For example, imagine that we selected 2 first-grade classes in the same school for the reading program intervention. The experimental group receives award-winning books and innovative online reading platform, while the control group uses traditional materials. If the experimental group participants end up sharing their books and access to the reading platforms with the control group, a contamination could occur. To prevent this from happening, it would make sense to select first-grade classes located in different schools and geographically separated enough that it would be unlikely that the kids interact after school. The next threat to internal validity is expectancies of experimental staff. This is when staff can't hide their enthusiasm about a treatment as opposed to the placebo to the extent that study participants catch on and react appropriately. And the final factor that could undermine internal validity is the Hawthorne effect. It happens when the treatment group changes their normal behavior because they're being studied. When experimental design is not feasible, quasi-experiments might be a good compromise. In quasi-experimental design, instead of a control group, you would select a comparison group. A comparison group is a group that is deemed to be comparable to the treatment group in key characteristics that are important for the outcome. Study participants are not randomly assigned, though, unlike in true experimental studies. A way to increase the robustness of quasi-experiments is to collect pretest data, that is baseline data on variables that are important to the intervention outcomes before the study begins. Once the study is completed, we would measure relevant variables in the comparison group. This is referred to as pretest, post-test design. When neither experimental nor quasi-experimental design is feasible, social scientists can conduct non-experimental studies. Non-experimental designs do not control for threats to internal validity. We will talk more in depth about non-experimental designs in the next lecture. Thank you for your attention and goodbye.